Okay, Mahinder, you would like to share your view about it?
So my understanding is is a something between the LLM and the agents or the tools, uh, the logic which bridges both. Probably,
Yeah, yeah, go ahead. No
yeah,
wrong
ma'am.
answers.
Yeah, yeah. Yeah, that is what I understand.
Okay. So there has been a lot of noise about both harnesses and loops until now. Everybody, whether it is Boris Cherny or Andrew New of Deep Learning AI or Eddie Osmani or a lot of other thought leaders in AI, they have all talked about harness and loops. And generally, we are all looking at the same thing from different angles. But basically, harness and loops both are not something new. We have already been doing some part of that already. What exactly is a harness? You already are using one harness today if you are using Cloud Code or Codex or anti-gravity for that matter. They are all coding harnesses, right? They are a framework from which you access your LLM and tell it what to do. Agree? So a harness is something you already have. If you ever created an application that was prompting an LLM and telling it what to do, or giving it the kind of framework within which the LLM could, perform, send back some responses, or was controlling an agent, that application too was a harness. So if we look at a harness, it's a framework. It governs how an LLM's actions are validated, authorized, executed, and logged. So it basically provides a set of constraints within which a model or an agent should perform. And if you want to give it an analogy, this is basically a configuration of a system. You are setting the parameters within which the system must perform. Uh, So that is also visible in the building blocks of a harness, what harness is made of. If you ever created a Claude MD file or Agents MD file or any kind of instructions or plans, you were creating a precursor of this harness already. However, you were telling Claude Code or Anti-Gravity or Codex what to build, but harnesses do something slightly different. They tell the system, they tell uh, the LLM that these are your parameters. You can only work with X tools. You can probably access, say, for example, Chrome for Cloud or Firecrawl or Figma plugin. Only these tools you have to use and perform this and this action. And it also gave uh, some kind of orchestration instructions. For example, when to spawn a subagent, when to hand over work, when to stop, and when to hand over something finally to the human in loop that it was going to do. And it also enforces some rules like when exactly you should the harness should compact the context. You already see in Claude Code, after a while, it when its context window becomes very big, it starts compacting. But here, you can create a harness and tell Claude Code, okay, you must compact every 10 minutes. Or after this build session, after the session end, you must stop there and compact. So that is your harness. Harness can also say that all such and such actions should be logged and probably kept in an MD file. Okay, I see that we have another. Yes. Hello.
Hi, Mukta.
Hi, Ravi.
How are you
Nice
doing?
of you to join. We have already started. So we already begin with definition of harness. By the way, have you seen that Google Notebook LM that I had shared earlier? It had some reference material regarding harness and notes.
Sorry, I've not checked it, and my apologies. I've joined in late, and I'm disturbing the flow. But yeah, I couldn't see that. If there is a way you can send it again or point me whether it
It's
is in
already
the.
there.
Okay,
You can
let
look
me
up the
just look at it.
chat.
Okay,
There is a chat, and in the chat, this link is already pinned for
okay,
you.
fantastic. Appreciate it.
And before you do that, Ravi, could you also share uh, your general idea about harness and loops, whatever, no wrong answers, what you believe they are, if you are already using them in your workflow, even better, and also state which coding agent you will be using in this session.
Sure. Yep. Okay. So, first of all, my belief is that we are now finding LLMs as more commoditized, and in order to differentiate the real power of AI, harnessing is going to be the layer that we all should be focusing on. The way I've been trying to do is that whether there are set of infrastructure and guardrails that I can create so that that kind of a harnessing it's actually more customized to my needs, to my kind of environment, to the level of protection that I want. From a loop engineering perspective, I believe this is, I call it slightly differently. I call them as living systems. And to me, the loops basically is a way for me to create a system that can update itself, it can maintain itself, it can grow over a period of time. And that is what I have been thinking from a loop engineering perspective. Help me understand if I'm going wrong, but this is my way of thinking that if I design a system, I don't need to be a human in the loop all the time, and system should be able to take itself to a next degree. And they
Mhm,
should be able to identify where there are failures or whether there are optimization opportunity और फिर उसके हिसाब से सिस्टम अपने आप को अपडेट करते रहे डेवलप करते रहे and whenever there are key decisions point they should be able to report it back. Uh,
mhm.
and I think you asked the third one, which agent? So abhi to focus Hermes pe hi hai. I am sure everybody's just doing Hermes. So I think this is one thing that I've been trying to learn myself. And the way
Mhm.
I've been trying to implement this, connecting all the three dot is if I'm using uh, maybe just a quick 15-second background. I am looking after partnerships at Flightbase. So all partner program, whether it is new partner onboarding, renewals of the partner, working together with them is something that I do day in, day out. So the way I've been thinking is, can I create my agentic workforce where my KPIs, which is let's say 3 to 5 partners every month that I need to onboard, that KPI become my agent's KPI. And then agent actually work with that as a mission and they continue to do the things that I am planning to do. They create those kind of a report. They understand that they are behind the target and things like that. And that is where they continuously improve. They create their own skills in order to enhance their own, I would say, kind of a workflow in order to meet the KPI. So that is a kind of a loop engineering I'm thinking for myself using Hermes. And थोड़े early stage में है. I think I have not completed
Mhm.
my implementation, but this is the way I'm thinking.
Okay, Ravi, by coding agent, I meant which particular coding harness you will be using here. For example, Cloud Code, Anti-Gravity, or Codex as such.
Okay, sorry,
But
Cloud
that's
Code.
okay. You can, Hermes happens to be an agent, which is something that you have to, autonomous agent, semi-autonomous agent, you can say, that will be working. We are not going there just as now. And what we are going to do is uh, try to see what you are trying to achieve, the kind of loops that you want, in which some agents run on their own and report back. Can we achieve that? So here we are. And okay, so I had started talking about Asad had a question, I think. Sorry, Asad. I didn't see you raise a hand.
Yes, actually, it's just adding on to or referencing Ravi's statement he made regarding Hermes. So personally, I'm just trying to understand what all LLMs do you work with, or like how do you get access to these free LLMs? Professionally, I do get these LLM credits by my company, but on a personal level, let's say I'm doing it for any hobby project or practice projects. Where do you get these LLM APIs usually from? The free ones, not the cloud hosted ones.
Yeah.
Okay, so actually, this does not pertain to this topic yet.
Correct. Yes.
What you do is basically open source ones are mostly available through, say, Hugging Face. You could try that. Most open source APIs are available there or via Olama. For others, commercially available APIs like Claude's API or say Open AI's. ChatGPT or other model API. So that is accessible via a payment. So you will have to pay for it, and you get against it some kind of usage quota that you can make use of. Ravi, you wanted to say something?
Yeah, I think
I
you covered it quite a bit. Maybe my 2 cent to that is I've also found out two free model on Open Router. And Open Router model, I think I've been finding them pretty decent. They have been helping in terms of all my day-to-day activity. And a free API is just registration on Open Router to use LLM like Owl Alpha and Laguna.
Mahendra has just messaged. He mentioned Grok. So Grok, which is acquired by NVIDIA, not the Grok with X. So GROQ. So that also provides access to open models, I believe. So you could make use of that. So Asad, we can move ahead, I guess, right? Your question is
Yes.
answered
Yes.
now?
Absolutely. Yes. Sure.
Okay.
Thanks.
Okay. So thanks for sharing all your ideas about what harnesses are. You more or less touched upon it that, yeah, you have a good idea what harnesses. What we can consider harness is a configuration of the system in which your LLM or agent will work. So if in Ravi's case, if you created a kind of framework within which, or set of constraints within which Hermes applies, you can say, Hermes, you have only access to XYZ rules. You can run for only, say, 30 minutes per day and only do one task, or any such kind of constraints that if you set, that you are creating a harness for it. Similarly, for Claude Code, when you are telling Claude Code that you're creating a harness.md file specifying that you have only this memory. These are the files that you can refer to. You have only these tools at your disposal to perform a task. You have only these many, attempts at certain tasks. All these count towards a harness. So this is basically a configuration of a system. Uh, Now, going to loops. Now, everybody from Purish Shani to Andrew New have talked about loops. What they mean by loops is that they don't write prompts anymore. They write loops that prompt the LLM uh, to run themselves. So that is a very interesting idea. Although we will examine how far we have actually come there, can we reliably say that we have reached that point yet? So, but anyways, at its simplest, a loop is just repetition of tasks, repeated execution of tasks, either indefinitely or at intervals or until a goal is met. You can say, uh, work on this particular application code base until you remove all the bugs. Or you can say that, babysit this PR. This is the most common use case. Babysit this PR until all issues are resolved. Or perform this action n number of times. I'll give you one example that I use. I have an application that checks AI providers' plans, your For example, Claude Code Pro or OpenAI Codex Go, their price plans or inclusions keep changing. So I have a loop that checks every week, goes to their websites and checks whether uh, their plans have changed, any information has changed. So that is one kind of loop. So it has a clear cadence that every week it should execute on a timer that at 9 p.m. or something it should do this particular task. It has a set number of tasks that go to XYZ websites, check these things, and bring back the difference if there is any. So this is most common sort of loops that you can build. And loops have a kind of their building blocks are uh, schedules that create kind of automations. There are work trees, there are skills that we tell them that this is the skill that you can make use of to perform this task. You have connectors that are basically plugins or tools that you have available, say Figma or say Firecrawl or say any other kind of tool that you want to provide. In case of Hermes, I think it also has a lot of tools that one can make use of. Uh, say marketing tool, uh, editing tool, publishing tool, any kind of tools there can be. Loops also have the ability to spawn agents. So what Azad said about tool agents, one is they're basically called maker and checker. One agent creates, one agent create code, and the other agent is checking that code, reviewing continuously. So that is also a kind of a loop. Loops also come with memory. So we provide a markdown file or a set of file system. You can say that this is the folder in which all the information that is necessary to perform these, uh, execute this loop is living here. So these things make up a loop. So if we look at a harness, I'm going to share my screen now. If you do diagrammatical representation, let me know when you can see my screen. So you see, this is, by the way, this is the same Google Notebook LM, and this page is available there, so you can see all these things later as well. So this is how a harness, if you put a diagram on it, will look like. It has instructions in form of MD files. There are capabilities that are basically your tools, skills, and MCPs. Yeah, MCPs also, because if you want to give them access to, for example, if you have uh, uh, access to say make my trip MCP and tell it to book your trip using only that MCP. You have enforcement like gates, stop when this particular condition is reached, or do not stop until this condition is met. Observability, like you are uh, this harness is telling the system that you must log every action that is this kind. For example, you deleted a row in a table, log it. Create traces. Also, keep track of the cost. Although I have not successfully been able to calculate the cost in terms of tokens, it's usually there is a variation there, but hopefully the systems will get better and we will have better APIs that calculate the cost or rather give us near real time cost of using a system, LLM. And finally, there's the memory. So once a session ends, you have to save its status or progress so that next time when the same harness is used, and when some other coding agent starts over, then they get to read that particular memory and remember what was happening last time. So the general idea about harness is what makes a model an agent. So a barebone model cannot do much. You provide it harness, you tell it this is your framework, you have to only work within it, then it becomes an agent. And one important thing about harnesses is you can record your failures because when you run harness or rather implement harness, not exactly run, when you have implemented a harness, a lot of things will break. There will be errors. So when you define a harness like this, take a look at this harness. It has memory specified. It has specified tools, gates, and rules. You can see a rule like never comment out a failing test, fix it or delete it. But you don't start out with the rules. You first put together a harness, implement it into your system, give it to your Claude code and say, this is my harness. Now, next time you start working, make sure this harness is in effect. So, and then watch over how your Claude code or codex or your anti-gravity will perform. And then watch over their failures. So what Ravi said about, hands off totally, that you are not going to watch what the agents are building. You will have to initially watch how this thing is working out because when the failures happen, you will have to turn them into rules after that. So every failure will turn into a rule. Like, for example, there was a hard-coded secret which created a security issue. So and the cloud code finds it later. So you find it when you find it, you create a rule like this: never hard code a secret, read from environment only. And it also says block any destructive actions like this RMRF or git push pause, which basically are overwriting what we have. Uh, you also have something like type checks, gates. You want to make sure that you move on to the next step only when type check passes completely or when your NPM audit passes. So these are your gates. Any harness would have something like this. Rules you can start adding one by one uh, after your failures, not start with it. But this is the general idea, what a harness would look like. So I'll ask you all whether you have any harnesses like this already in place. What would you add to it? Do you see any additions that we can make here? Even your own project, you can add some, what kind of additions you would make, what kind of information you would add to harness. Asad, you want to add something?
Anything related to maybe structured output? Structured output is something that I think is of great importance when it comes to dealing with these agentic
Mm-hmm.
systems. What goes in, what goes
Right.
out, how it goes in, and how it comes out.
Mm-hmm. So where do you think that would go? Would that be some kind of a rule, or we will have some other section like, structured output and you define
Separate
that?
section, separate part, I would say, like memory tools, gates. So similarly, we'll have something called a structured output rules
Mm.
or input
Okay.
output rules.
Okay. All right. So now let's move on to loops. So loops, as I've already talked about, it's a repeated execution of tasks. whether uh, my own idea about loop was something like that. It was a while loop that checked for some condition until it was met, and it was triggered by some kind of cron job, right? For example, uh, the example that I gave, check for AI provider plans every week at 9 p.m. and it has to run every week, and its job is to find any differences. If any difference found, do this. If no difference found, do that, like that. This is one kind of loop example. And a loop would be something like this. It would be, it would have a trigger that starts it. It could be something by, schedule, periodically run every week, every day, or say every 1 hour, something like that. It will tell agents what to do and also spawn agents, basically, sub agents rather. So it will tell that this thing needs to be done, and for that purpose, create as many agents. It will have some kind of check for goals to be met or not met. If the check passes, it exits. If fails, then it reprompts. So that's what Ravi was talking about. If the checker, if the goal is not met, then reprompt the agent and make it do the same thing over. And this is also something that we have heard to be called as a Ralph Wiggum loop. Use the same prompt again and again and again. Tell the system that this is what needs to be done until it gets it right. And just like harness, you will see that this is common. Harness also has a memory. It also records status or progress. Loops also record them in progress assembly files. Because if the loop stopped midway, it has to record that this is where it stopped so that next time it starts, it remembers where it had stopped earlier and pick up from there. Or maybe start all over from the beginning. So this is what a loop would be. And now let's talk about engineering. Okay, we have so far talked about what harnesses are and loops are, but what do we mean by engineering? Does it mean coding? If you had to create a harness or a loop, how would you create it? Anyone? Would you write a code for this? Maybe a Python program for this? Or maybe something in a JavaScript? How would you go about it?
I think in my mind, it's still going to be more natural language.
Hmm. Right. So uh, we don't do this, we don't need to code a harness or a loop anymore. You can simply create an MD file. For Cloud Code, it's harness.md. I think this also applies to OpenAI as well. So you create these harness.md files or agent.md files and give these files to Cloud Code and say, now this is a file based on this, create a harness. And it will automatically code it for you. You don't need to hand code it anymore. And we have already seen a harness, what a harness looks like. This is the general idea of a loop. This is also MD5. And this is a nightly triage and fix. It basically works the same way as uh, just like a CI/CD pipeline. Its job is to create a nightly uh, triage of any bugs that are found in a day's build and fix them on its own, and also save whatever it has fixed in the progress.md file. If it failed or any bugs remain open, it put it to Progress MD5. So this is pretty much straightforward. This is in natural language, and you don't need to code. You can provide this loop file to your respective application where you are fixing these bugs, and tell say Cloud Code or Codex or Anti-Gravity to run this loop every night for you at fixed time. So I have also created some more examples for you for harness and loops. Here's a coding agent harness. It defines uh, the task. So basically, it works on this thing that various tasks exist, and you have saved them somewhere. And this coding agent's job is to define a set of rules in which those tasks will be performed. So we already have something like read the progress MD file, uh, break the tasks into smaller tasks, and create plans and perform audits. And at the end, after execution, make sure that you save the status. When to do the handoff, what are the limitations? All these things are written here. Similarly, there is a research agent, deployment agent harness is also there. There is also example of loop. So the harnesses that are here, they have almost their companion loops are also there. So if harness X, then loop this will be used inside it. You can take a look at this file. This is available in this notebook LM. These are the files that are referenced here, which I'm showing you now. So this is it. One thing I wanted to further touch upon, how these things work together. There is a section about how they work together. So loop is the top layer where your loop instructions live. Harness is something that makes sure that those instructions are performed within a framework of constraints. They get logged. The output that is generated is logged. Any issues that are there are getting logged. There is a memory to guide the actions that are there in the loop. There are gates to check whether certain conditions are there. So this is how the top layer of loop and the harness layer that is below it will work together to create the systems that you need to build. So I hope it makes sense. Do you want to add something to it? Do you think something else should be there? Or do you think that we do not need separate harness or loop? There was also this interesting observation by somebody saying that we don't need two separate things. A loop can also include harness.
Loop is time bound, right? And harness is something that is independent of time. Loop
Yes,
requires a
correct.
harness, but a harness won't require a loop always.
Harness can work for anything. It's not necessary. Loop is basically
Exactly, yes.
repetitive executions, but harness can also work with one-time execution also. You don't need to, Uh, but harness works really well when you are making, harness is really good to improve the performance of loops. One common example that is given is of post-training of models that are loops. So loop instructions for post-training of those models are tied with harnesses, which already have some constraints. And that harness alone improves the model efficiency post training because of that. So, because if there are any unusual behavior or the model post training is showing some unusual behavior that gets caught by harness and is logged, and then harness can again uh, inform the loop to fix that. So, there is this kind of interaction between the two. And they can share information via their memory because the files can be read, the status MD or progress MD files can be shared among the two. Okay, Ravi wants to say something. He has raised his hand.
Yeah, Mukta, I think I was trying to understand and maybe put this question on the table for clarification. When we are talking about loops, would that be equivalent to the living systems, right? Uh, if if you know where I'm going with the idea of living system is something that actually help in terms of innovating itself, right? That is why I believe we are talking about loops also, which is like deciding how to keep going until you reach to a mission or to a milestone.
Mhm. What we are talking about, the definition that you gave me of living systems is kind of pretty broad. I don't say yet that we have reached that level of maturity because a living system would be totally hands off. You would say that, okay, this is your software, create a CRM, and these are your instructions. This loop will continue until the CRM is completely created. This is the final gate. But what you will see eventually that human in the loop is much more necessary initially. So this living system that is totally hands off, that condition is not met. So you will have to be there. You will have to do a lot of uh, what should I say, approvals. You will have to course correct initially until the system reaches a level of majority when it captures your intention correctly that it can move on its own. But yeah, it is far better than the original prompt by prompt method where your approval was necessary every time. So the living system, exactly, hands-off system, not yet, but eventually you will get there once it matures. Do you agree with that?
Yeah, I think there is nothing wrong or right about it. It's just that we are in the early stage and we haven't really seen any case studies of this kind of implementation yet. So this is still early. My only idea about leaving system or even loops is even though it may be small, it may not have completely matured, but can we start something which can create a system? And this is also about a mind shift change. That is where I wanted to start thinking in that direction that whenever I'm designing a new solution or a software, can I start thinking in terms of a loop system or a living system that maintain also itself, right? So when I'm talking about it, it could be very, very simple. Let's say just scan my emails, right? And that system actually start scanning my emails, understand the pattern of the emails, then start drafting the responses about the email. Also understand, let's say, the exceptional email like out of office, so that I don't start writing immediately, but check that out of office is a for a week and then only reply it after a week and so on. So that is where the system also start building the skills for themselves over a period of time, saying these are the patterns, and then it continue to maintain itself. And then I really don't have to take care about those small nuances and do not have to add that back into their skills or into their guardrail, saying, okay, if you see this, you have to do this. But then the system is intelligent enough to understand those patterns and then derive conclusion out of it and then continue to evolve. And this is where I'm thinking that even though I would start small, but the way I wanted to envision is that
Mm.
how how a system start thinking and design all those observations, understanding, and then start crafting them into some kind of a, let's say, either a skill or maybe kind of do's and don'ts, and then start maturing itself over a period of time. And then there could be very limited touch point where a human would come in, and eventually the human may not be required. But yes, we have to start thinking in that direction in order to reach to that point, and we may be early, but I think this is very fascinating concept that I'm feeling, where we might use AI to develop solution, but we rather use AI to let them develop a solution.
Right. I'll take your example of partners onboarding. Let's imagine your business requires partner or onboarding, and it is done once a week. You have new partners coming in all the time. You batch them, and there is onboarding that happens once a week. And you can also say, in case of say employees in a company, let's imagine once a month there is a general onboarding. Let's take that example. Now, you start this process, you create a loop here for onboarding. You define the steps that are okay, get their details, create a record for them in the, your ERP or whatever employee system, and then issue them these and these resources. Then next, create their salary accounts or payment accounts and things like that, assign them an ID. And this is the general starting of the loop. This is one thing that happens on its own. And you run this loop and see, uh, run this alongside human observation first, then reduce the human observation to minimum, and then it can run totally hands off. I think that's how it will work. So we create the system by first observing and then uh, gradually reducing, incrementally or rather, not exactly incrementally, gradually reducing our observation, and one day totally hands off. That's how we can go about it. Uh, what it will require, actually, initially, we will have to watch out for all the caveats, all the gaps, all the places where things break, and record them. So, and also teach the same thing to the loop. If something breaks, log it and share it with the human for review so that they suggest what to do. If we are going to say that loop will know all by itself what to fix on its own, it will be probably a little bit too early. I have discussed this already in this article that I'm showing right now. Initially, it does require course correction, but after a while, it is pretty good to, it's pretty much on its own and it can perform on its own. That's possible. So, couple more topics I wanted to share actually. One was portability. Because, say, I write a harness for a system that I originally built in Cloud Code, and then because Cloud Code costs go pretty high, and I decide to switch to Codex. So, what happens to my harness? Can it shift easily from one system to another? So luckily, there is a lot of portability possible, and at least between three major providers, this portability exists. So what you just need to do, take out your MD files and just place them to another coding agent, and it is able to replicate the harnesses and loops at their end. So have you people tried that by any chance? Not yet. That would be an interesting exercise because we see that many times, for example, outage of Fable 5 showed us that our AI systems, AI ecosystems are pretty fragile, and we suddenly may find that certain model is not available. Or it may also happen that we might have to use different ecosystems because we already exhausted our usage limits for, say, Cloud Code. Now we want to run it for GLM. Sorry. Yeah. So GPT-5. So in that case, these kind of portability will help that you have actually a chain, a loop consisting of three different systems, one cloud code, one codex, and one anti-gravity, and one exhaust. You can switch on to the next and the third, like that. So that also can be a good example of a loop. Uh, there's also the uh, point of cost, because when loops are running, you will notice that there's very little control over the cost, because if there are multiple sub-agents being spawned and each sub-agent is making use of LLM cost, so what exactly uh, will be the cost? Can we keep a control over the cost also? So far, my attempts to control this, because say Cloud Code doesn't allow me to directly say that do not spend more than 100 tokens on this task. It does not actually uh, play heed to that instruction. So if you are running a loop hands off and it actually exhausts all your usage limit for say a month, or runs a very high bill, how you can prevent that? So loops should also have that uh, cost cutoffs in mind. Find ways to make sure that whatever tasks are being performed, they do not cost beyond a particular threshold. A threshold is clearly set by means of API calls. We're actually going and checking via Cloud Code API how much is the usage so far. If the usage reaches X limit, stop. So rather than giving in harness command like an instruction like do not go beyond 1000 tokens on this particular task, you will actually have to write code here. That cannot be done right now with, say, an NB file, unfortunately. You will have to create some kind of programmatic way to do this. That keep checking what is the usage and stop when the usage is reaching this particular threshold. So, this is what I wanted to cover so far. And this is the last point about why do the loops still need you? Because initially, as I said, things will break earlier because you don't have all your intent very clearly codified in your MD files. So there is all the likelihood that the loop will do something that you didn't ask for, or is performing something altogether different, misunderstand your instructions. So in that case, it's important to initially watch all initial runs of the loops and then step away only when you have the confidence that, yeah, it is doing what you have taught it to and it is following the instructions to the T. Okay. And apart from these examples that I have created for harness and loop designs, you can make use of these as a template for your own harnesses and loops. There are three kinds of harnesses and same number of loops that you can make use of, uh, and maybe make them your own, create your own variations on them. And on top of that, there is something more. These are the command references that I have created. If you are running these implementing harnesses, which commands are available to you in Cloud Code, Codex, and Anti-Gravity, and to run loops, the commands that are available there for the same. So this is the reference that you can make use of. I see somebody else is joining.
Sorry, Mugdha, that was me. I have to
Oh,
drop off for another call. But this is very insightful. Appreciate you taking all the efforts in order to share the information.
Yeah, actually, what we wanted to do after this was to build. Uh, there was an exercise that
Mhm.
I had created. If you want to,
I may have to drop
okay,
off now, but
go
is there
ahead.
a way maybe I can ping you on WhatsApp and you can share the exercise? I can try it async.
Yeah, you can. Actually, this will be in your notebook LM itself. You
Okay.
can access it. It is on a GitHub repository, so you can access it, copy the clone the repository, and try it at your end.
Okay. Fantastic. Really appreciate that. Thank you so much.
Bye.
Thank you.
So, Asad and Mahendra, would you like to try that exercise?
Yeah. So now, the thing is, Mugda, I mean, I also
Mm-hmm.
pasted that question into chat. The thing is
Mm-hmm.
like, uh, I am building my thinking on top of like when I started using Chat GPT and then functions in 2023, 2024, somewhere early in that period. So ultimately people started calling, I mean, functions were streamlined and then they are basically being called as a agents. That's what my understanding is. I'm just trying to fit my understanding about the orchestration frameworks along with this what I will say, the React loop, corrective rag, etc. So these
Mm-hmm.
all methodologies people talk about with this harness engineering. So I'm just trying to uh, merge those understanding with this one. So
Mm-hmm.
why harness engineering is something being talked about? I mean, what is the difference or similarity between these two or the whatever what I was talking about. So I mean, is it possible for you to just give some differentiator or the thing that uh, that will clarify this understanding?
So, to paraphrase what you just said, you want to know why we are talking about harness engineering now, if I understand that correctly,
Mm-hmm. So we have
right?
orchestration frameworks. They have
Mm,
the capability you mentioned, most of them, and then
mm,
there are many what I will say patterns, agent patterns. You can use like React and then Graph, etc. etc. So there are a lot many things are being talked. So where do harness engineering fit into that, or is it a totally a different thing than what I will say? So what I understand from it. So
So, harness engineering came into being because humans wanted to step away from the machines and
mm,
let machines do their thing. But they also realized that when they did that, machines didn't give the kind of output that they were expecting. Machines often, because of the context rot or the
mm,
context window being full,
mm,
or just because some instructions were not correct or the machine did not understand it, the outcome was very different. So, which is why there was this need to say that, okay, we will clearly define the rules within which uh, the machine creates something, code or content.
mm,
That was the reason why harness existed. You mentioned earlier methods of performing something. Harness actually is not very different if you see. You also would do something like that, I believe, in DevOps, right? You create some kind of environment in which a software has to operate, right? You
mm,
create, or say, not even DevOps, I would say something like SecOps, security
mhm,
operations, when you are actually creating the security, uh, what you say, scaffold, in
mm,
which basically tells a system that these are the security rules to be observed. You cannot stray beyond that. You must adhere to these rules and you must, if you fail to adhere to it, you will stop working, something like that. So things like that, these are already there in, they exist in non-AI, uh, uh, what is, should I say, system.
Hmm. Uh,
But
yeah.
this is uh, because harness engineering was needed because humans wanted to provide these kind of rule books, I would say, in natural language to models, which is why the harness engineering came into being, nothing else. Otherwise, you see the same patterns that we learned from security ops, they are still here. They're
Hmm.
practically being implemented the same way, but in natural language, not by programs. And you're telling this to your coding agent or your LLM for that matter. Okay, I'll take a moment to welcome Shivam Kavare. Hi, Shivam. You have joined us a little late. We are already midway.
Hello.
Hello, yeah. So, Shivam, hi, this is Mugdha. I'm your host for NightBuild 3. You unfortunately have joined good 1 hour late. So, you missed most of the part actually of we discussed already loops and harnesses. So, we are now talking about what is the need of harness engineering. Would like to add something there? You have any questions?
No, but I know little bit about the harness engineering.
We lost you there. But
Hello.
anyways, Shivam, do one thing. Go ahead and whatever question you may have, you can put them in the chat. I'll try to answer that at any.
Yes, I think network issue.
Okay, great. Okay. So, Mahinder, I hope I could convince you that harness engineering is nothing new. It already
Hmm.
existed in some forms and it is just being put in the current form for this particular purpose. You already
Yeah.
had
So
debugging, you already
yeah.
had security ops.
So like when we see say the harness engineering, we as a like, even building the agentic system, we consider all these possibilities like setting a boundaries, giving it a tool, and letting it run in a loops until it find the it execute or it able to get to the point or the to the result. So I mean, but it isn't had any name till now. Like that, what I'm thinking. People were talking it separately. Now it has a name like harness engineering,
Name, yeah.
like vibe coding. Yeah. So the thing because that's what was confusing me because like as I understand, initially you just give a prompt, you get a response, then you tell in a prompt that yeah. Uh, I have these two situation or the functions where I need a if if something similar or like if you have to make some this decision, you just tell me you have to call this function or that function. So that is how function calling was introduced into GPT 3.5 or somewhere around like 4.0, and then that is kind of wrapped and then that got a name as an agent. I mean, internally it does the simply basically segregating the function call and the response. Uh,
Mhm.
yeah, and we call it as an agent. I mean, that's
Correct.
what my understanding. So here it again, I'm trying to relate it with the what uh, I'm experiencing around or whatever I'm doing, and then how why harness engineering is like, is it something new evolution or it's just name for the practice people follow.
Right.
So yeah, yeah.
Unfortunately, AI domain is famous for coining new terms every week. It kind of
Hmm,
gives impression of new things coming up. But
hmm,
that's basically something that already existed. If you
hmm,
wanted to prompt a system with, say, make use of 100 tokens only, although
hmm. Yeah,
that's not exactly how it works, but basically you could do that earlier as well. Now you
yeah.
are just putting that prompt in an MD file and giving it beforehand via a primitive of a
Mhm.
harness or a loop, right? That's basically a written instruction given to the LLM, just like
Mhm.
a prompt. It's only you are
Yeah.
providing it in a different way. The difference here is now the thought process has changed that you cannot let LLM run amok
Mhm.
without any constraint. You are trying to control the LLM's behavior. If you remember, there used to be hyperparameters that we used to play with on workbenches.
Mhm.
So we used to control the temperature, we used to
Mhm.
control, streaming and all that.
Yeah.
That were kind of precursor to this. But now
Mhm.
we have gone beyond that, and we are also telling in a harness that this is your memory. These are
Mhm.
the minimum tools that you can make use of, or
Mhm.
do not make any deleting or any actions like that, destructive actions. So
Mhm.
these kind of things we have started to tell the
Mhm.
LLM, and LLM is understanding them. That's the only difference. Earlier,
Mhm.
if you did the same thing via prompts, there was
Mhm.
a chance the LLM didn't understand because it didn't know what to do with that kind of prompt. Now
Mhm.
LLM understands, and you are just providing extra primitives,
Mhm.
command or something, so that the LLM recognizes, okay, this is a harness that I have
Mhm.
to make use of and apply for the system going forward. So that's the only difference. Other than that, that knowledge existed. It's only getting applied to AI with a fancy name of harness. Nothing else.
Yeah, even eval for the sake of eval,
Correct.
when we talk about enforcement of the rules or the checks, if it's going correct and where it need to be stopped. So eval is the pretty
QA.
old, yeah. So like,
Eval
yeah,
is QA, right?
yeah. So I mean, ultimately, considering eval, React, like basically loops and then graph rag and etc. etc. So if you combine everything and then call it a harness engineering, uh, the process through which like
Mhm.
you make sure that uh, agents do their job correctly without crossing their environment or boundary.
Boundaries.
Yeah,
Mhm.
so that we call harness engineering, but ultimately it's just concept like the combination of entirely so many scattered stuff into one single thought process or what I will call it. The
Correct, correct.
process, yeah, yeah.
And however, I would like to, there is a disclaimer here that even if you specify a harness,
Mm,
whether the LLM will actually stick to it
mm,
is something that we still have to check via evals. I'm not
yeah.
focusing on eval here right now,
Mm, mhm,
but it's a topic on its own. But basically, what we provide as a harness engineering, basically, you're configuring the LLM, right?
mm,
By engineering, by providing that MD file that you engineer that.
mm,
There is no guarantee that LLM is actually sticking to every one of the rules that you have set.
yeah.
So it's a broad level guideline. You cannot even call it a guardrail yet,
Mm,
unless Claude Code says, sorry, Anthropic says that we ensure that harness file that you provide is absolutely followed to the T.
mm,
And same with other providers. These are general level rules. For example, in an unruly class, a teacher says we will do X things, and students don't care about it. It's just like that.
mm,
So they are rules, but whether they will be followed, we will have to keep an eye on it. That's what I was trying to talk to Ravi about. That, yeah, it seems to say that you can create a loop that can self create itself, continue
mm,
building, but that
yeah,
is not actually 100% true yet.
yeah. I mean, yeah, it will take time to
It will take
evaluate to
time,
that
yes.
level. Yeah.
So, yeah. Um, okay. Anything else that we want to discuss further in this? One thing I wanted to actually focus on was the cost. Unfortunately, there was some interruption. But uh, if you have made any forays into that when a loop runs, how to control the cost of building in every loop? Because if you are saying that a loop can run continuously, take example of a cloud code window, usage window of rolling window of 5 hours, right? Can you create a loop that says, okay, you run through the whole window, but the loop ends when the window ends, by the end of the window, start only when the new window begins. Or rather, stop when your usage is completely exhausted, and then start only when the new window begins and you can start afresh. That unfortunately hasn't happened yet. And this is what we should first try to achieve in terms of cost. Can we control the cost of the loop? Then we can go ahead and do the loop full-fledged, because then we will have a guarantee that whatever we are building is not creating something garbage, one thing. And secondly, if the cost is in control, it is not going to run a huge bill resulting in total garbage. Okay. So, can we move ahead to the exercise that I have set up? Would you like to try that?
Yeah.
Other than mine? Okay.
Yeah, I think yeah.
So,
Okay.
what I have done, I have, let me first quickly explain what we are trying to do with that exercise. Uh, you will have access to a harness and a loop. Uh, they are created for you already in a GitHub repo. You can clone that and make them your own and run through your own systems. What that loop is about, it does a very simple thing. On a website, there is some kind of pricing page of some commodity. Now the loop does this. It runs at interval of 3 minutes and checks that page whether the price has changed. Something like your stock, you can consider stock market, right? A loop is checking every 3 minutes whether the price has changed. If there is a difference, it comes back and does something. This is what the goal is. So you will have the part of uh, uh, kind of, you can say, price watcher. I, on the other hand, have the other part of it in which I'm going to run a loop at my end where I'm changing the price every 3 minutes. You people okay with this? Does it make sense to you?
Yeah, we can give it a try.
Okay. So here we go. Here is an exercise. This repo contains the files that you will need. You can clone it. Okay. So I have put the file, the GitHub repo link in the chat for you. You can clone that repo. Take a look at the harness and loop files there. There is also a README file. I'll open it now and I'll share my screen. So here is your repo. You will need to install Node if you don't already have it, and Git as well. So here are the steps to perform to set this thing up. So I have on a website a JSON file which has prices. Imagine like I am the stock market and the prices are changing of stocks at my end. And you are the client app. You are reading from the changing prices. So these are the files on which the prices will be changing. And at your end, you will run your loop via a command that will be giving you the difference. You already have a copy of those prices in your repo, and every time your loop runs, it finds the difference between the prices. It comes back to you and asks you whether I should, loop asks you whether it should update that price in your local. Does that make sense? Okay.
Yeah. Mm, okay.
And you also have an approval.md file, right? So you give approval when these are the various runs that it should happen, right? Run 1, run 2, run 3. It asks you if there is a difference found, it asks you to approve the change, and the change is made. Next time, the loop runs again and then again compares. So there are total three runs of this loop. Let's see how it works out. All the files are here, and you can take a look at the harness and the loop. This is your harness. It has a pricing catalog and a diff.md where difference will be saved. Approval. It will record what decision you give, whether yes or no. Okay. And here are tools. You will fetch the prices, and if there is a diff found, it will report. It will write to this diff.md file. There is a verification gate, and this is the human gate where you will have to respond. So this is a basic harness. Let's also take a look at your loop. So your price watcher loop, it will run for every 3 minutes. These are the conditions that it will check for. It will just go to the URL that is already hard coded here. If it finds any differences in the price in your local and the price on the website, it will ask you for approval. This has a retry policy. There is a diff format already specified. There's a notification contract also. What kind of notification should be there? So this is where we are. Go ahead and clone and let me know when you are ready. So you will run first time this loop at your end, and then let me know. I'll run the price change at my end after that. Okay, have you cloned it? Let me know.
Yeah, but I need to install Node.
Okay. Take your time and let me know when you are done. By the way, while you are there, could we take a snapshot actually? If you turn on your respective
Yeah,
cameras,
yes. Yeah, yeah.
Okay, thank you. And taking a snap now? Thank you. एक और हो जाए. I don't know what's wrong with this. This is region. Yeah. Yeah. Yeah, I think I got it. Okay. I see that you have sent a file. Thank you.
Now I'm inside NightBuild exercise 5, and then
Mhm.
it says that you need to go the check the specs. So uh,
Yes,
something like
you can go through README.
Mhm. Yeah, I'm going through README. The steps
Mhm.
is like clone and then go to the directory and then just check the harness.md and loop.md. So
Mhm. Actually, there should be something else. You provide this to your coding agent. It says something.
okay, should I open it into anti-gravity?
Yeah, go ahead. Actually, there is a node command that you will have to.
Mhm.
Step 4, if you look at it, there is one command first to check whether you can access that URL where the pricing page is. And then you have to run node to start the watcher, which is basically checking for pricing change in that remote URL.
Okay.
You'll find that in step number 4.
Hmm. Okay. The synth JSON and then the uh,
Mm,
yeah,
right.
both. Yeah.
So what happens now? You go to Cloud Code, you say, I want to run this loop. This
Mhm.
is my file.
Mhm.
This is my loop.md file. I want to run this loop every 3 minutes. Give me the loop command for the same. So you don't run these commands by yourself, the node command or curl command, whatever. You ask Cloud Code or anti-gravity to give you the command that you will run from them, from their CLI. And they will run these commands at 3 minute intervals for you.
Okay, so instead of me running node watcher uh,
Mhm.
with the schedule parameter, so I should ask agent
Yeah.
anti-gravity
Mhm.
to go into the README and then try executing the steps according to the documentation, sort of.
What you will say, this is my harness.md file, this is my loop.md file. I want to make sure that you honor, by honoring harness.md, run the loop.md
Mm.
or the
So I
instructions
should
in
say that
loop.md file.
you have to follow the instruction given into harness.md and then
Mhm.
run the loop.md. Check necessary
Rather
conditions.
follow, yeah. So
Yeah.
what you basically ask, actually, I was wrong. I said run loop.md, but it should be by reading loop.md, give me the loop command to
Mhm.
execute at X interval, whatever. Read loop.md command and give me the corresponding loop command to run. I hope that makes sense. What you have right now are the building blocks. You are
Mhm.
not going to run each command by yourself because this is not what loop does, right?
Yeah.
What you have already specified your constraints in the harness MD, and what you have is a loop MD file also. You provide this to your coding agent, tell them that you have to run it, or Cloud Code or Anti-Gravity or Codex have to run it. You don't run it.
Mm.
I suggest you share your respective terminals one by one, what kind of input you get out. When you provide these files to your coding agent, what happens after that? Is the
So I
coding
open
agent able?
entire like mm, directory inside the anti-gravity already. I'm just trying
Mhm.
to put a prompt from the prompt window.
Yes, actually, same thing. What I kind of did is cloned the repository and gave it the access, and
Mhm.
one by one, told it to go through the README,
Mhm.
and it's asking me questions also. Okay, should I do this? Should I do that? I'm going through it
Mhm.
and parallelly allowing it the access one at a time.
Okay. Could you do a favor? You share your respective mm, coding agent window here.
Sure, sure, yes.
So Asad goes first, then Mahendra.
Just a minute, just a minute.
Okay, I'll try to focus on this. Actually, we are unable to. Mahendra, can you see the text?
Yeah, it's
I'm unable
blurry.
to. Yeah, we try to focus on this. Highlight. Now it is much more clearer. Okay, so it is installing Node. Fine. Okay, it is even editing the watcher. Does it give any reason why it is editing the watcher?
I'm the watcher for the first time using node watcher. Yes, sure. You need to watch your that.
Okay, provider JSON updated. Just a second. Let's read this. It's asking for your approval. It has saved the approval. Okay. You wait this time. you don't give the approval right away, I'm going to change the prices at my end.
So for me, it went into the loop and trying to execute everything. Node watch
Hmm.
edges, okay.
So this is what it is supposed to do. This is what a loop is supposed to be. It is continuously performing certain tasks. Right now,
Mhm.
it is asking for your approval. But if you set a kind of approval uh, instructions as well in advance in MD file and tell my approval rules are already available here, it will even be able to automate that.
Mhm.
So you can actually do this that first couple of times you decide up, accept or reject, and third time onwards you let it run on its own. Okay. Meanwhile, here's what I did at my end. I'm also running the kind of a loop at my end. I'll also share my screen. So what I have at my end is a command to update uh, the pricing page, which is called synthai.json. JSON. It's basically just a JSON file where the prices are being updated. And this is another. There are three files that are getting updated. So this was run one. Then there was another run. And now it is ready for the third run. So you can see there are two loops running in parallel. One loop is updating the prices, and your loop is actually, what should I say, reading the updated prices and updating your local copy. This is what is happening. Right now, it is asking for your approval. That is human gate. You can remove that if you want and try playing that at your end. Mahendra, would you like to share your screen? Your
Because yeah,
screen?
I don't basically understand what I need to do. So I need to quit and reopen before sharing.
Okay. Okay, you're back. Go ahead and share your screen then when you are ready.
So here we are. Basically, I just ask it to go through the readme MD, consider harness.md and loop MD as and execute necessary commands as required. Please ask it. Can you suggest what should I ask in the first thing?
It would be easier if I see your screen, then I would be able to say.
You are not able to see my screen yet?
No, not yet. Asad, can you see it?
Yes, it's visible.
I'm the only one who cannot see it. Okay. Let me see. Ah, yes. Okay.
Okay.
Okay. What you have to do is basically this is your directory. This NightBuild 3 exercises.
Hmm.
Open this directory. You have already done that, right?
Yeah.
Now, what you say to this is anti-gravity. You
Hmm.
say that this directory contains a harness and a loop. Read both files and determine what kind of loop it is and give me the command to run it or determine how to run it yourself.
Oh, this good. Oh, I mean, something similar I asked. So the directory contains.
Yeah, you have already asked. Go through the README MD, consider harness MD loop and execute necessary commands as required.
Mhm.
Okay, yeah, this is what you just need to be done. So what did it say? I successfully completed, met all requirements. Okay, okay. What it did not do actually, it says that I completed this and this date, but it has not executed the same. Three files changed. Okay, you see here at the bottom, you see three files changed. Let's see whether it updated the JSON files. Oh yeah, it has. See,
Mhm.
it actually did that.
Okay.
The price amount was changed. It
Mhm.
was 25 to 20. Again, it happened.
So while
Okay,
it was
so
running, it basically fetched the change price from whatever you were running, and then it just updated it into this JSON.
yeah, it
Is
did
that
not
correct?
stop for your, yes, exactly. So
Mhm.
it did not actually ask for your approval. It just
Yeah,
did
I asked
make the
it
change.
to go and do necessary things. Yeah.
Okay,
Maybe I
okay,
can run
which
it
is why.
again and then, yeah.
Okay, we can try once more if you want.
Mhm. Maybe like this.
Okay, what is it is actually trying to do that zip file should not be there. It is trying to unzip that file for some reason.
Mm-hmm.
So this
So,
kind of things happen, and
mhm.
which is why we need to watch the loops initially. It is supposed to be doing something, but it does something else altogether different.
Mm.
How would you like to handle the pending pricing updates for run ID? You see this? You
Yeah.
say either accept or reject, whatever you want.
Yeah.
Whatever decision you took was recorded in approval.md.
Mhm.
You see, the runs are documented here. First run ran the watcher, which was successfully outputted. 8 differences in the pricing plans. Interactive approval, sorry, the second run and the final check. It did run. So I hope that gives you some idea
Mhm.
what a loop run is supposed to be. Now imagine you were, um, what should I say? You have a list of items in your daily grocery purchase that you are purchasing from different places.
Mhm.
Say one from Amazon, one from BB Dairy, and another from elsewhere. Right? You have a list, you have a loop going that actually checks their prices at various places,
Mhm.
right? Amazon and elsewhere, and gives you the differences and asks you, should I go ahead and buy it?
Oh, yeah.
Does that make sense? That kind of loop.
Yes.
Let's
Yes.
take another example here of onboarding that I was trying to talk about with Ravi. Same thing that when before onboarding, you check certain criteria about that a particular partner,
Mhm.
whether that partner passed their security check, whether they not security background check. There is some police and verification and all that.
Mhm.
So whether their certificates that they submitted are verified, whether they passed background check, whether they are available right now and they have signed the agreement, then onboard them.
Okay.
So these kind of things happen, and then they it comes back to you and asks, shall I start the process of onboarding now?
Mm. Okay.
Or even that also can be automated. You can say approval.md already has the details of my approvals and rejections in the past.
Yeah.
Refer to it and make the decision going forward.
So
So
yeah,
this is how.
even
Mhm,
so, when we are coding through this anti-gravity or even Claude, we like certain preconditions, the boundaries or the rules into Claude.md or sort of kind of file, and then we
mhm,
uh, add this along with our project, and then ask it to follow the rules which are given into there, and then just
right,
stay in the boundaries. So
correct.
I think this is some sort of another kind of harness engineering where we code with the coding agents or the coding tools, and then we also have like we gave us some conditions which like the boundaries or condition which need to be followed.
Right. So it has actually both here. You
Mhm.
could actually remove the harness altogether if you want and see how it behaves.
Okay, huh. So
And so
without
even that way, even
Mhm.
without harness, this should work. Then loop does not have any kind of gates around it.
Yeah,
Then loop
yeah,
will not
so
stop after 3 runs. It will
right,
continue running indefinitely until you
yeah,
actually exit that session.
so it will either go with the whatever written in the prompt and
Mhm.
uh, follow it at its own, as long as it thinks it can go and do execution, or else
Mhm.
follow those rules in the MD files. How
Right.
much, like, yeah, the rules or whatever the boundaries, those are written there.
Here,
I
what
think.
happened? The loop was supposed to stop at the after third iteration.
Mhm.
So that was a gate.
Yeah.
Once you reach third loop, third iteration, stop after that. But if you remove that condition, it will continue to run.
Yes.
If you
Yes.
don't have a harness around it saying that you cannot make the change directly yourself, it will actually go and update the JSON file at your local without any, asking you anything. So that will happen. So this is a very basic, I would say,
Yeah.
very
It's pretty.
simplified,
Yeah. Even we
but
need to go through the harness. I mean, detailed code, whatever you have written. Like for loop, you have written certain loops. What I will say, the
mhm,
small block of the codes. So what rules need to be followed, etc. I think I need to like we need to understand in deep,
mhm,
and then find out like whatever we are doing, how we
mhm,
can implement that into our own implementation.
right. And the good thing about it, I wrote these loops and harnesses in Claude code, and you have
Hmm.
run this in anti-gravity. You can see there is a portability here.
Hmm. Hmm.
So anti-gravity in both cases, Asad, you are also using anti-gravity like
Yeah.
Mahindra. So there was some change in
Yes.
the beginning. You saw that it gave a command, it gave a kind of a narration that it made changes in some file,
Hmm.
the watcher file or something. So it did make changes, but it was possible for it to follow the same instructions that were created for Claude Code in
Hmm.
anti-gravity as well. So there is a
Hmm.
portability also established that way. Now, what matters here is the cost. Something that I was not able to successfully implement here. So,
Hmm.
a kind of homework for all of us. can we tell our coding agent, anti-gravity codex or cloud code, that by means of harness, that this is the maximum cost or this is the threshold of spend in means by means of tokens or by
Hmm.
means of API costs that you can make, and you cannot go beyond this. If you are exceeding that threshold, stop and alert me that I'm stopping.
Yeah, I think that should be possible, right? What
The
do you say, Asif?
most right,
Yeah, we can keep on calculating. Some like the very initial implementation when we implemented even chatbot and it used to basically it for every conversation it was basically calculating the entire how many token it has consumed. So somewhere we can fix the rule like where is the limit
right.
and yeah. That should be
No,
possible.
that's the
I just want to,
right, right.
I'm just trying to understand in this context and how do we do here. But otherwise, that is something can be implemented like the way we do otherwise through the line graph, line chain, and then other frameworks sort of uh,
Right.
the way
What I
we
see,
implement. Mhm.
right, right. My idea was slightly different. I was going to make calls to the API of, say, Cloud Code usage API and
Mhm.
find out every, by means of the same loop. Uh, I'll have a parallel loop running in which I'm calculating the cost for every run. And if
Mhm.
in a particular loop, the cost is, and I'm deducting that from my the threshold amount. If when it becomes zero, I stop. That was my idea, but I'm sure somebody will come up with something better. This is one way to do it. There can be better ways. So you run two loops instead of one loop, MD5, you have two loops.
Okay. So yeah, I mean, I will also go into detail and try to figure out the solution into this context. So what I
Yeah,
understand,
we
it
all
should be
can.
a possible. Yeah, I mean, it's just counting tokens, and at one point you have to just stop it at some point.
Yeah, so loops do spawn subagents.
Hmm.
So loop is basically there is a super agent that is spawning sub agents. So can we say that all the agents that are spawned, one agent is specifically for watching over the cost?
Yeah, maybe. Yeah, or even the one agent will take a look at all agents and how much they are consuming. Uh,
Right,
and just reporting to the parent agent.
right.
See,
So I have come to see a loop more like a sprint in our agile framework, how our software development teams used to work.
mhm,
One loop or one iteration of it becomes one sprint in my
mhm,
software development lifecycle.
mhm,
So one loop end to end has everything. So there's one more thing I that comes to my mind. Like we have cycles of QA or security reviews
mhm.
within each sprint. Could we
Yeah,
have a loop within a loop? I have one loop which is for delivering a feature, and inside that loop there are sub loops, loop within a loop. So there is one loop that is taking care of bug fixing. There is
mhm,
another loop that is doing the security review. There is another loop that is doing some kind of compliance checks.
mhm.
So these loops, once they reach a particular gate, certain thresholds are reached, they stop, and then they give a go or no go signal to the parent loop.
Parent. Okay.
Whether that is also, yeah. They say, I have found, I have fixed all bugs. I'm good to go. I stop now.
Hmm.
Security says that I have finished all security checks. There are no more. I fixed all security gaps and I'm good to go. and compliance says, I found no compliance gaps, you can go ahead. And then the loop completes, its gate
Mm.
reached, and it stops. Or it
It,
goes into the next iteration.
okay, yeah.
There's a
I think I need to go into dig deeper into this particular topic. I was not into this. Basically, I was not following the loop engineering or harness engineering much. I just had a couple of times like read some text and try to understand, yeah, what it might be. And I just thought it's just something like it is just a name given to the things or the engineering practice people following these days. So I didn't go much deeper into that. But yeah, I think we'll dig deeper and then try to find out this particular solution. How do we estimate the cost and how do we stop it in between when we reach to that point?
correct. And we can collaborate on this going
Mhm,
forward if you want to share. After this event, if you have any observations from your own experiments, other than Mahendra both, you are free to share them uh,
mhm,
either on your LinkedIn post or blog, whatever, or even better, you can add these observations in the notebook LM. You
mhm,
create a copy of that notebook, you share that information in that notebook and share it back with me that
yeah,
I've added these and these things. So I'll
yeah,
make it into the master copy as well, whatever
yeah.
you find.
So for another week or two, I will be like a bit busy with the preparation of my certification,
Mhm.
uh, cloud engineering certificate. So I've just bit diverted from there, the current whatever current developments. So maybe I will come
Mhm.
back to this after like
Yes,
a couple of
perfectly fine.
weeks. Yeah,
Perfectly fine. But there is some value here.
yeah,
Agree that it is a fancy name given to something that already existed, but it gives us a natural language interface into the working of LLM, and
mhm,
to a certain extent, we can make it work in ad infinitum in infinity to do something for us. It's a
mhm,
great tool if we learn to harness it
mhm,
and make it do what we want to do. That is basically to build enterprise class software with it.
yeah, yeah,
This is true value. So, guys, we are already at the top of the hour,
yeah.
and go ahead, whatever, if you have anything to share, whatever feedback you want to share, go ahead and share here. And one more thing, I'll be sending out a, feedback form, a very short one. Whatever you want to write in it, go ahead and write. Those people who will give me back a filled up form will get Deep Learning AI coupon code for Deep Learning AI Pro, which is kind of
Ah,
there are special courses that are
mhm.
only available to paid subscribers.
So basically,
The-
the videos are free, but if you want to go through quiz and get a certificate, then you need
no,
a
those
pro.
courses themselves are different. They are
Okay.
very in-depth courses. They are not
Mhm,
1 hour courses. They are much more
okay.
in-depth and have more information in there. And
Mhm,
what you get if you fill up the feedback form, you will get a 1 month of a Deep Learning AI Pro coupon code
mhm,
that you
mhm.
can apply and get 1 month of that. So
Okay.
you
I
can
think
actually get what,
Mahendra sir is I think also part of the deep learning community, I guess.
Yeah.
but he
So
doesn't know about that, right?
Okay, interesting.
yeah, recently I am not following. I mean, the problem was like from January, I'm bit away from this all the stuff that like
Right. I know
I had a
that.
tinnitus.
Mahendra, yeah.
Yeah,
Actually, Asad, he is my co-host. Actually, I recruited him to join as co-host. I was hoping for more people. It didn't
yeah.
happen. But
Mm.
basically, he's always there as a co-host because he's also a fellow deep learning AI
Yes, I've attended
ambassador
two
here.
of his sessions, offline sessions in Pune.
Yeah, yeah, of
Yeah,
course.
yeah. So I'm planning another one soon. I'm just in touch
Mm,
with couple of speaker potentially maybe I mean uh I'm just looking out some interesting topics. So there are a lot of stuff already on LinkedIn and YouTube and everywhere. I'm just trying to find out
Mhm.
some niche stuff which might be interesting to talk about. For example, geospatial intelligence. Uh, uh, Processing satellite data and then how to find insights out of it. Kind of. So there are a couple
Mhm.
of speaker. Those are like PhD holders and then head of some department. So just trying to reach out to them, and then if they are ready to speak about their journey till now. So maybe that I'm looking out into that direction.
Symbiosis, I think, has one geospatial department.
Mhm.
So
No,
you
no, no.
can
I am in touch with someone from what which company
IIT.
is that? Not in from IIT. Just a
Okay,
second.
I'm stopping recording so that we can have this conversation,
Yeah,
right?
yeah, yeah.